currently sunny.
Oh, okay. Phew, okay. I was getting confused. All right, my bad.
Go flooding. Yeah.
Huh.
Okay, I think we're.
Is your internet connection in that case, Simon, or is it just on my side?
It seems fine on mine.
Okay, cool. All right.
I think it was cutting out a little bit for me too, but you sound fine now.
Okay. Whew.
All right, I think we're live on YouTube and LinkedIn. So hi everyone, thanks for joining us. I'm just finishing up setting everything up and passing the links over to our host to capture all your questions, and then we'll go ahead and get started. But we'd love to have you chime in the chat, make sure our audio sounds good, and we'd love to hear where you're joining us from. All right, get this link to you, Denny.
Yeah. And while Karen is saying the logistics, Simon and I were bantering about the fact that for some reason both Seattle and Kent are currently sunny, which is sort of odd. So for those of you that are on LinkedIn or on YouTube, or for that matter Zoom, go ahead and tell us where you guys are based out of. Listen, this will be pretty sweet, right? Oh no, we're host, buddy. Simon. Looks like my boss Ali's on board, so we're gonna screw this up royally, aren't we?
So we have to have it so it actually works this time.
Yeah, I know, man. We're really host. This is gonna be bad, man. Oh no.
That's right. I fixed it.
Did you really fix it? Did you really fix it though this time? Come on.
I fixed the magical mistake that I idiotically made, so it's fine.
No. I will take ownership of that mistake too. I do want to call that out. Because it did require us to actually practice, which we didn't do.
All right, you two. Let's get started.
Okay.
I have a few. I have a few intro slides, and then we'll go ahead and get started to the session. So I'm just going to share my screen here. Okay. All right, so welcome everyone. We're happy to have you. This is part 2 in a Tech Talk series with Simon and Denny. Today they're going to be talking about schema drift and data quality. And this is the second part in their Tech Talk. And the first part, at the end of the session, we had a poll where we asked what you'd like to hear about next, and this is what you voted on. So again, we have another poll at the end of this session. So we hope you'll chime in the chats if you're on LinkedIn and Zoom, and then the LinkedIn and YouTube, and the poll on Zoom. So that'll be at the end. So we can have you kind of help us figure out what we should talk about next. So quick call out, these sessions are part of the Data plus AI online meetup group. So if you're joining us from Zoom, that's probably where you found us. If you're joining us on LinkedIn and YouTube, we're happy to have you. I invite you to join our meetup group. We have a lot of upcoming sessions, including a couple meetups for Summit, which is in a few weeks. But there, if you join the group, you'll be notified and you can see all the details in advance and check out what we have coming up. Lots of different tech talks, AMAs. We also have a data collab lab session with some folks from our field engineering team. So lots of great content there. And all these sessions are recorded and they're available on our YouTube channel. So I'll drop these links in the chat spaces so you can review the sessions at a later date if you'd like to. And so I wanted to give a quick call out. We have season 2 up, Data Brew with Denny and Brooke Wenig. So this season is going to be focused on machine learning from research to production. That's our first episode. I believe there's a few more episodes there, so I invite you to check out that podcast series. Really awesome content. And they have interviews with folks in academia and industry, and they discuss different topics, including data ethics, production grade infrastructure for ML, hyperparameter tuning, auto ML, and tons more. So there's the link there. And these podcasts are available wherever you get your podcasts from. So I'll drop that link too. Lots of links after my intro slides, like usual. And then I have to call out our summit coming up. So we're super excited. Our Data plus AI Summit 2021 is coming up the end of this month. So May 24th through 28th, We're just about 2 weeks away. It feels like it's coming up fast and furiously, but we're super excited. We have over 200 super technical sessions, lots of content there. We have some amazing keynote speakers, including Malala. We have Ali, our CEO, Matei, who's also one of our podcast Data Brew guests, and many more. So I invite you to check those out. Registration is free, and then we also have some training on the first 2 days. So check out the sessions, and our DevRel team, I know we have some free training codes. So if you're interested, please ping me, and I might be able to get you one of those codes if you'd like to take a training for free. So hope you'll join us there. All right, and just really quickly before I pass it over to our guests, Simon and Denny, quick reminder that the session is recorded, and I'll drop the link in the chat spaces. If you do have questions, Denny's doing his best to capture all those questions. So hopefully we'll have time at the end for Q&A. So with that, I'll pass it over to Simon and Denny.
Perfect. Thank you very much. So Simon, why don't you present your screen, since we're going to be doing the session off your screen again, and hopefully this time the connection will be okay.
Yeah, I have since re-networked my entire house. So I'm hoping things are okay. Unless it's my neighborhood or my country, then it should be okay. We should be all right.
Yeah, well, you should have really figured out that global synchronization for compensating for country outages. Come on, man. Yeah.
Okay.
No, but in all seriousness, so just as a reminder for everybody, don't forget, this is where we build a thing. This thing is a lakehouse. And so actually, why don't we, just to remind folks, because this also will remind you and me what we're doing, why don't we start off with what did we even build? What was the environment? And then we'll jump into the autoloader, the mistake we made in the tail end of the first session. And then for everybody that's jumping on board, what you'll notice is that we want you to ask questions, in fact. So whether you're on LinkedIn, Zoom, or YouTube, ask your questions. We're going to do our best to answer those questions live, but that's the context. So
there we go. I even made a picture. Ah, look at that.
No way. You actually did?
I had this last time.
Oh, that's right. Actually, you see, this is reminding us that we forgot about stuff like this. Okay, cool. Why don't you present that, my friend?
Cool. Okay, so I build a thing. Essentially, you've got a thing called the Open Movie Database. And that's just like a little open source thing that's going and scraping things like IMDb and Rotten Tomatoes and all that kind of stuff, and just presenting it as a, hey, you know what, if you just want to find out how did the TV show do, what do people think of a movie, that kind of stuff, you ping the API and it gives you some data. So we made a super quick little thing where we grabbed just like a handful of TV shows, and we said, little bit of data factory, which is the Azure orchestration tool, go ping that API, grab some results, store each result as a separate JSON file, and sling that over into our environment. So basically, we're pretending we've got like some third-party vendor sending us data. It's out of our control. That's in Simon's tenant, and we have no control over it whatsoever. At least Denny doesn't. I do. From that point, we've got this landing block. So we've got like a storage landing point. We've got kind of a nice place where data is being sent every day, and then that's where we're starting. So we're like, right, okay, so let's actually get started working with it. And we spent a lot of last time doing like the architecture review, here's how we built it in Azure, here are the things you need to have clicked for this to work, doing all the security setup for autoloader, making sure it's got things like a service principal and connections and permissions and all of that stuff that's needed for things to work. So getting all the way through it. So a little super quick recap of those.
So before you flip, I just missed it. My timing was wrong. So I'm curious, did you not let me access, with Simon's tenant, did you just not let me access it? Was it because you didn't like me? Or is there a real business reason for why you have this?
Well, obviously I don't want you to see everything else I've got going in my tenant, because there's all sorts of garbage in there.
Fair enough.
Professional pride in terms of letting people, it's like you see my camera, you can see this view, you can't see the piles of boxes and things that are just out of the camera view. It's that kind of thing. I'm giving you a little view.
Fair enough. Okay, point taken. My apologies for bringing that up. I apologize for doing that. I apparently hit a line. My apologies.
But we get that a lot. There's lots of like software as a service tools. if you're going on to like some, and you get just a web portal and they're like, yeah, we can send you data. Where would you like it to go? And you've got no choice about where that, it's like, you just get sent data. And loads of clients don't have that. Loads of people, you've got access to the source system. You can go into the database, you can extract data, but it's getting more and more common as you get more and more cloud services that, yeah, you don't have control and you can just say, put it there, please. And then people just deliver you data and then you got to deal with it.
Perfect. My apologies for breaking the flow, but I thought it was an important call out because as more and more customers are exactly to your point, are building up their cloud environments, the reality is they don't actually have control over their source systems in the first place. And so you actually have to build systems in place to basically compensate for that fact and almost default to that as your starting point, as opposed to assuming that you have full control right from the raw source, right? There are systems that you will, whether it's API calls or anything else, that you won't have over control, and that's okay.
Yeah, I mean, and so certainly the way people build Azure subscriptions, it's like, I think there's a client of ours who had, a couple of thousand Azure subscriptions in their organization because they're growing, they've got lots of sub-organizations, they're a big group, and each group has like the IT function and then their website and then the data function, each has their own subscription, and then you just multiply it out, and they've got so many, and it just grows and grows and grows and grows. So yeah, it's fairly common cross-tenant data sharing madness.
So how do you really feel? How do you really feel? I'm not sure if I can tell.
Oh, it's great. I love it. It's fine. But it's fine. You make it work. Look, it's
yeah. Fair enough. All right, let's enough banter, my friend. Let's go into maybe showing what the portal looks like. So we provide the structure, and then we can dive into autoloader and then continue on.
Yeah. So this is the let's go small. These are the bits that we built, nice and tiny. So we have thing one, which is our landing blob, obviously, because we weren't good at naming things. We've got our lakey thing, and that's the lake. So when we've got our medallion architecture, when we've got our different structured bits of data, where we've done something to pick up and shape the data, that's all in the lake. Whereas we've separated the bit that the vendor might have access to. So if we're giving someone write access to say, yeah, you can write data into the lake, we don't want them writing to any part of our lake and messing up our good data governance and putting it in the wrong zone or any of that stuff. So we said, that's your separate abstracted thing one. You're allowed to put dump data in there, and then we'll come and ingest it into our lake. So we've got control. We can have it nice and neat and organized. We can put shelving up. It's good. That's what it should be. And then we've got a vault. The vaulty thing is our credential store. So all secrets, we don't want to have things hard-coded in our notebooks. We don't want source control to have our passwords. So the vault is our password store. And then obviously we've got Databricks, which is doing all the things. All of the things. We haven't talked about that because we didn't make that. So,
yeah, did I do that? Or you did? I forget.
We didn't even touch it. That was created magically by Databricks.
Oh, that's right.
So when we do autoloader is going to set up a notification service in Azure. That's a thing called Event Grid. And that essentially just fires a message anytime a certain event happens. And the event we're talking about in blob storage is a blob created. Someone's landed a file, therefore it triggers a message. That message goes into a queue. And then that's the thing that we can read to go, has anything happened since we last ran it? And there'll be a load of messages sitting there and we can go, yes, please. And we can read them all up. That is the plan.
Right. Actually, one thing I did want to call out that from the standpoint of actually, at least from last session, why autoloader, why the event grid system topic. So an important aspect that we want to call out is that when you're trying to read cloud object storage, if you're trying to just list files, this can get actually really, really slow. The more files you put into it, basically, the longer it takes to even just do the listing of the files, let alone actually go read those files. So the whole premise and the reason why autoloader actually can speed things up significantly is because it makes use of the fact that cloud object stores themselves actually will fire events. Anytime a new file goes into the cloud object store, basically an event is sent. And in the case of Azure, it's Event Grid. AWS, by the way, for S3, they also have their own events. The point is that we can track those events. So for AWS folks, by the way, it's SQS, but nevertheless, irrelevant of which one you're using, the point is that the queue itself, there you go, perfect, shows actually a bunch of the messages instead. So that way we can read the queue as opposed to listing the files. And so because we can read the queue, then we can basically just simply grab the file with the full file path, as opposed to saying, hey, list me out 1 million files, go grab that, and find me the one file that I need. Instead, we have a queue right here, as Simon has wonderfully shown, that actually shows exactly which files that we need to go grab, and bam, there you go. So it actually significantly speeds up the ability for you to process your data. So just wanted to call that out.
So there is a slight issue here in we've not ran it for so long. There's no messages in the queue. Oh, there we go. I was putting the wrong queue. So that's one of the weird things. If you're using autoloader and you just do a display, so I just want to say, I want to see what's in there, and it triggers and it runs. It's going to set up those notification services for you, and it's going to start tracking things. So there's a little bit of a cleanup. If you're just testing things, you might want to go and clean up any orphan ones, because it will create ones each time. But okay, let me own up to my mistake. Let's go and have a look at the thing that wasn't working. So we got to this point where inside our notebook, we were saying we want to get a load of secrets. We want to configure our cloud file stuff, and we've got, this is how I want to connect to things. And that one is very important. That is how it should go read that queue. So basically, how does Databricks connect to see this list of all the files it should go and read? And that's via a SAS key, a shared access signature key. So I'm going to show you how you generate one of those. You go in here and you go, I would like a shared access signature. And you tick a load of boxes going, this is what I would like it to do. And I'd forgotten that it automates and goes, this is going to expire tomorrow. And so the one I created was a 1-day key. And so it obviously expired by the time that we hit go, and we got a horrible error and it didn't work. And it was nothing, there was nothing big we'd done. I just simply not remembered to put that way in the future so it didn't expire. That was my mistake. That was it. I was too quick. Next on all the buttons.
No. The real mistake was the fact that we actually prepared and did it. We practiced yesterday, right? Like, so next time it teaches us that we really should stop preparing ourselves for these events.
Yeah, I mean, we should have people live telling us in the chat going, dude, set the date, idiot. And then we know.
Yeah, that's true. That point taken. Fair enough.
Okay, so running through, we can just, we tend too long introducing ourselves. The cluster has turned off. Give that a moment. I can show you what it looks like. So you can see I ran this 30 minutes ago. Only half an hour ago, this was working. And you can see it's just gone and read a load of JSON. So it's got a load of files from, we said it's the Game of Thrones one. And that is just reading in a load of JSON data coming from that blob store. That is autoloader in a display way. Just go and just tell me what's in the thing. And then it's not really using the message queues. It's just going and saying, well, if we're going to stream it, I'm going to go do initialize it and read everything that's in that folder structure. And then it stays open as a streaming query. So keep query. I should have left it streaming, wouldn't I? And then it wouldn't have turned up. I'm saving you guys money. That's it.
so then there's a couple things that we're missing here. Like, first of all, we should have turned it on to streaming, so then when that would have shut off. Second of all, we probably should have enabled warm pools so we could have actually just accessed that too. So tip for everybody that wants to do a live session, don't do what we just did. We should have either ensured our cluster didn't shut off so quickly, or we should have streamed it, or we should have warm pooled it, and we did neither of those things. So this is
20 minutes of activity is a bit.
Yeah, that's a little aggressive, my friend.
We will not spend money on this show, but it's fine. It's fine. We'll get it working.
Fair enough.
Okay, so we're at this point when we've got data landing and we figured out a thing that can let us read the data, right? So the main thing that we've said we're going to try and do today is to land the data, to slap it in a lake, which makes sense. So we've got I assume we're going Databricks Medallion Architecture, we're going bronze, silver, gold. Is that the way forward?
I think so. I mean, it's all about data quality, right? So for those of you that may not be familiar with this concept of like what the Medallion Architecture is, the whole premise is that as you land your data into your data lake, you're going to leave it in basically the bronze form. And that's why we say medallion, bronze, silver, gold. What's bronze? The context here basically is saying you are going to need to land the data into your lake as fast as you can with minimal to no modification of the data whatsoever. And the reason it's actually important to do that is because a lot of the systems, whether you're like reading API calls or anything else that you're trying to extract the data. The reality is there is a bunch of data that you need to basically pull in from your source as fast as you possibly can. And because you're going to lose it, right? If you don't grab it. Now, if you design it really well and your source system actually is well designed, sure, maybe you can go back through some checkpoint, request for that data, and you're good to go. But the reality is you can't always trust a system that you don't control, right? In this day and age when you're very much where you don't necessarily, especially in cloud environments, where you don't actually control the source systems, all of them, all the source systems that you're trying to read, you're going to really just try to get that data as fast as you can. And so that's what that bronze portion of the Medallion architecture is, as Simon has so eloquently drawn about fast and low checks.
You will learn that my handwriting is hilariously bad, but it's fine.
Yeah, but you forgot to put color, dude. Come on, man. You're oh, dude. No, I'm joking. Okay. So
no?
There you go. See, that's better. Come on, man. You gotta help me out here a little bit. Right?
Okay.
But yeah. No, but seriously.
So one check on you.
Oh, go ahead.
So for me, I call that raw, bronze. It's fine. Naming. It's a 3-stage architecture of curation, and things get curated as you move through the process. That's fine. So for raw, I would never dedupe. So if someone sent me 10 of the same records, I've still got 10 of the same records when I'm in raw. And then if I'm trying to dedupe and do that kind of data curation and validation and chuck out bad rows and stuff, I normally do that moving into silver. So kind of that's going to normally for me is the fewer checks as possible. Just get the data in. Doesn't matter if it's slightly wonky. Just get the data in. Doesn't matter if the data changed. Get the data in. That's our normal philosophy. And we'll talk about schema drift. Oh.
Exactly. So and now one of the things that I definitely want to call out basically is that, especially because both Simon or I are both Microsofties, like in the Microsoft ecosystem, I guess, and like former SQL Server, BI, data warehousing guys, right? And then both of us are independently came to the conclusion, lakehouse, right? It's all about lakehouses, but why? Well, the reality is because you're going to be dumping all your data into a data lake. It's the cheapest, fastest location to dump your data, okay? And because you're often getting so much data that you don't actually know what to do with that data, because you're going to need to get it landed first, and then you're going to worry about it later. And then exactly what we called out, like as a 3-part architecture, silver becomes where you do the transformations, and gold is where you do the aggregation or feature engineering. It's very akin to, or analogous, I should put it this way, to the data warehousing paradigms of the past, where you basically had an OLTP system, a staging database, and then you finally had your data warehouse, right? In which basically it's about transactional throughput, get the data in as fast as you possibly can. Then you're going to stage it where you can do third normal form or whatever transformations that you typically will do. And then you built your dimension tables and your fact tables for your data warehouse in order to be able to query it. So if you're coming from a data warehousing perspective in the past, that actually still matches. It's just that this is the data quality framework that you want to apply to your data lakes in order to build a proper lakehouse, right? That's that concept of saying you have your data lakes, but you're applying not just some of the technologies that you can hear from data warehouses, which is why we talk about Delta Lake so much, because the idea of ACID transactions to protect your data. But we also want to talk about there are actual key tenets or key philosophies or designs that we take from data warehousing that actually makes a lot of sense when it comes to this type of data, because exactly as Simon called out, at the bronze, you don't want to dedupe. You don't want to do any of these things because you just got to land the data as fast as you possibly can. But then when you transform from bronze to silver, akin to the OLTP to staging, yeah, you're going to dedupe. You're going to join with other tables in order to figure out what the dimension keys or whatever else you're trying to do, right? And then when you go to gold, that's where you're going to aggregate it up. And so that way, whether it's machine learning to do feature engineering, or whether it's do aggregation, so you can go query the data. So you have BI type queries, whether it's a Power BI or it's in the Photon engine with Databricks, whatever, right? The context is that you can now have super fast queries coming back. So that's basically the crux of it and why we care about having that Medallion architecture, because in the end, it is about data quality, right? you only get the value of your lakehouse is based on how well you were able to go ahead and ensure the quality of the data by the time you get to that third stage, that gold stage. Hopefully I didn't overstate that. Simon, anything else do you think I should add?
No. No, it's exactly that, right? It's nothing new. Like that kind of idea of warehousing and curating a data model. It's just applying it to a new tech stack and doing it in smarter ways. But the principles and approaches still absolutely make sense.
Bam. Okay. So for anybody else that is from LinkedIn or YouTube or on Zoom, by all means, please continue to ask any questions. Hopefully these contexts that we're talking about make a ton of sense. And then we'll soon shift back once our cluster is back up and running. Like we said, we should have done streaming. We should have reset the time, or we should have went ahead and set up Whirlpool. So that's our bad. And yet another example of this is what happens when Simon and Denny build a thing live and don't actually practice.
I think from the title, people assumed it wouldn't be that slick. It's fine.
Yeah, I would assume so, but you never know, dude. Okay.
However, so there is one thing, obviously, so schema drift is a big thing at the moment, right? With autoloader. And actually it's almost like, I promised that we didn't plan this, but since we did the last video, you've released schema drift for autoloader. So actually we can use the new functionality where we couldn't have used it last time. So it kind of makes sense.
Yes. Yeah. No. We planned this.
Yeah.
Yes. That was exactly how we set this up. Exactly. Yeah. So I don't know if you're watching me, but I'm doing the Simpsons, So I digress. Yeah. By the way, kill cell 3. That was me messing around. My apologies. So. Yeah.
Okay, well,
sorry about that.
Let's formalize this anyway. We've got a thing that actually works.
Please.
I'm gonna bang it into. Let's do it properly. Gotta get some organization going here. So we're building something to process things. So I'm gonna create a little folder here, something called processing, and then we're gonna have our number one thing is the acquisition layer, getting data in. Let's clone that, bang it in processing. Call it step 1 is. What, into raw? Autoloader into raw? Acquire data?
Autoloader acquire source. Ooh.
Acquire source.
Yeah. It's not sauce, dude. Source.
Fine. Okay. Cool.
That's for later, not for now, dude.
So we got this. We can get rid of that. We're not going to display it anymore. Okay, so this is our basic processing thing. So the thing that we've got to do first, yeah, that's what it's called. It's the official name. The thing that we've got is how do we want to handle drift? So we've got 2 approaches for handling drift. Well, 3 approaches. We've got the I don't care, I don't want to know about it, don't tell me that drift happened, which is the ignore anything that's not in our original schema. We've got the break if drift happens, and then let me fix it, or automatically kind of fix yourself, but still fail and resume. Or we've got the, I don't really care about anything extra that comes, but I don't want to have to worry about it, just dump it into a extra data we didn't know we were expecting column. So we need to make a decision about how we do it.
Yeah, should we ask the audience if they want to be participating in this, or should we just do what we think is right? What do you think?
It depends how chatty the audience are today. If they have
I don't know. Yeah, audience, do you have an opinion on whether we should go with 1, which is basically don't go ahead and care about it, which is, you just don't care. Number 2, where you basically are saying, break it. I want the sucker to fall apart and, and you go fix it. Or number 3, we have this nice additional column that allows us to put the extra columns inside there. So you can easily let your data continue to process. And then you don't actually have to worry about anything. And then you can subsequently go ahead and process data. I don't know if I'm doing a pitch very well. What do you think?
I feel that was a slightly leading question.
I don't know. I would never do that. What are you talking about?
Okay, well, we have, let me, here's one I made earlier. I've got a load of extra config, and we can just decide which of these bits that we slap on. So we've got that cloud file connection stuff. We've got the how we're going to deal with drift as our extra bits. And we want to bang that into there, which is, we're not using that anymore. That can go away. And we're going to use this So essentially, some of these extra options coming from this drift conf will bung in here. Oops, definitely need that. Okay, so which extra options should we turn on? So firstly, we had a whole JSON schema that we were doing. I've gotten rid of that. We're just going to infer the schema now. That makes life easier. We need to tell it to store the data in our lake under some kind of sample area. So if we're going to use schema inference, if we're going to use schema drift, we need to tell it where to keep a log of the schema, because it needs to know what the schema was, so it knows if it's drifted. So it has to store that somewhere. So we'll give it a location in the lake as to this is where we're going to allow it to store stuff. And then we've got these options of, do we want to rescue the data, which is the one where it creates a rescue data column and it bungs all anything it doesn't know into that rescue data extra column, which we can then just go dumpster diving in to find any attributes that we didn't know we expected. Or we can do add new columns, which is the one that ironically fails it, but then updates the schema. So when you restart it, it's already expecting the right schema and it just continues. So do we want it like self-healing, but it'll still fail and have to restart? Or do we want it so it doesn't store the columns properly, but it's never going to stop? I like rescue.
I personally like rescue, but the only reason I was pausing is because I'm looking at LinkedIn right now. We've got one that says break it, one that says the third option was rescue, one that says don't care, just keep going if there's new data. It looks like we're saying don't break it at least. But yeah, let's go with let's go with the rescue option.
Okay, so if we go with don't break it, that's rescue. We'll ignore particles for now. We can fix that later.
Yep.
I'm going to leave out schema hints and we'll just see what it infers. So we'll let it do some inference. I'm not that fussy about the choice of inference it uses. So these are all new cloud files options. So it's going to infer column types. We're going to give it a location. Right. We're going to let it rescue. And then it's going to, by default, it puts it into the rescue data column. And we can get it to, we can give that a fancier name if we want to, but that's fine for me.
No, it's fine. And a quick call out. Then the context is just because I'm answering some things from LinkedIn. The idea is that we never get stuck, right? We won't get stuck. We'll continue processing. So if there are changes to the data, no big deal. We're good to go, anyways.
Have I not mounted the lake yet? No, I haven't mounted the lake yet.
Well, that would be problematic, wouldn't it?
Well, that will require me playing around with keys. So I'm going to say just give me a second. I'm going to quickly mount the lake off screen.
Okay, perfect. So again, now this is what happens when we do these things live. So nevertheless, the context is the reason why we're trying to mount is so that way there's basically direct access. So that way we can acquire the data from the mount. Relatively straightforward. You're going to do that in almost all your environments, whether you're talking about Azure or AWS or Google. So you're perfectly fine. But the context basically is in that way, there's a constant feed from that mounted data lake, and we can throw all of our data there. Again, as what Simon was calling out. Oh, I'm sorry. I just realized I'm a little blurry today. All right, there we go. What Simon was talking about is that basically we're going to go out of our way to infer the schema to make sure that when it sees the data in terms of, is it like a string? Is it an integer? We're not going to specify what it is anymore. Okay. In the first session, that's exactly what we did. We actually specified what we expected the data to look like. The trick, by the way, is that if you don't know, you could always infer the schema by reading one of the initially reading the JSON files or whatever files that you had initially, reading the schema, and then printing out the schema, and then boom, there's your schema. Okay, so then you can always build the schema that way. But the idea was that over time, what we're concerned about is that the schema changes, right? So hence what we're talking about inferring the columns, right? So the idea is that if there are changes, we will go ahead and initially infer the schema. If there are changes, guess what we're going to do? We're going to go ahead and actually prop those columns that we don't recognize and chuck them into that rescue data location. Hopefully that makes sense. I did say that right, Simon? Or did I actually completely get that wrong?
I think so. I wasn't paying attention.
Okay.
Sure.
Oh, fair enough. Oh, fair enough. Okay, point taken. Okay.
So it's currently mounting the lake. So that's going to just take a moment while it then matches that up. The other thing that we need to do is actually security. Oh, the exciting thing that is lake security.
Oh my goodness. You mean
I
we
know,
actually have to secure this stuff? I thought we could just leave it out in the open and let everybody read it.
I know, right? All right, let me quickly, I'm going to draw another super quick picture.
Okay, cool.
Switch over. Apologies, I need to turn branding off. So we've got
No. Are you trying to imply branding? I couldn't tell.
No, never do that.
Okay, cool.
All right, so we've got our root lake folder, right? So that's just one big structure, and we can give it we've got the blob key, and that just gives you access to absolutely everything. That's like brute force. I want access to everything in my potential lake. Then inside there, because we're using ADLS, we're using Data Lake Store, that has hierarchical namespace, meaning we can create folder objects which are securable. So we can use POSIX security and say, well, you're allowed read access to that folder, you're not allowed write access to that folder, and we can secure it at a finer grain, which is the whole point, which is really, really good. So I assume that our lake structure is actually going to be, kind of that kind of bronze, silver, gold folders. And then we can secure those. So we can say, well, data engineers, because we're trusting them to get into the nitty gritty, they've got access to raw. But like our business users trying to run some reports, they don't have access to gold. Oh no, they have access to raw. They have access to gold, but not to raw. You've got that kind of match our business security to our people. Now, the issue with ADLS is if we go and create a load of data in there, and then we go and change the security that's at the root folder, that doesn't trickle down nicely. You have to build something that recurses and resets all the stuff, which is fairly painful. So best practice, if we set the security up before we start loading data, then the data as it gets added has the right security applied. So before we start landing data in the lake, we should have a think about what the security looks like and just set a few basic things on the root folders. Is that fair?
That sounds like excellent advice for anybody that's building a data lake. So the actual act of security should not be done at the last possible second. Is that what you're trying to imply? And so that's the call. Yeah.
Lakes do have a reputation for not being as secure as other things and all that kind of stuff, which is entirely untrue if you actually think about security up front as part of your design.
Right. And that's another important thing. Don't forget, for a lot of folks who are building these data lakes, right, you do have GDPR and you do have CCPA compliance that has to come in, right? In terms of not just securing the data, but also ensuring that especially from a GDPR perspective, if you get a request to delete said data from the lake, you need to have the ability to track it, know what you're going, basically be able to remove that data from the lake. This is part of the reason, by the way, that we all, this is just a minor plug, but we actually have a tech talk series, part of these tech talk series. We actually had one specifically for Delta Lake and how you would apply that within the GDPR and CCPA instance. So that way you could actually delete the data from your environment, from your data lake, but with ACID transactions to protect the data. So that way you could actually see what's going on. So you actually could delete it and actually have a transaction log that makes it very clear that in fact the data has now been removed, right? So it's an important aspect and an important part, and this is part of the reason why when we're building our lakehouse here, that we're using Delta Lake to do it, so that way we can ensure that we have all those transactions that track everything for us.
Cool. And I guess when we get to build, we'll talk about table access control and using that as a different security layer.
Absolutely, yeah. When we get to the gold layer, then because there's always like who's allowed access to basically the aggregates versus the features versus anything else. There'll be generally you're going to make it more open, but then there's an implication of when you build your gold tables, exactly what level of depth or level of details, that you're going to provide in there, right? Some people's there's aggregations are still very detail oriented, and you may or may not be able to allow folks to actually have access to that because of the security context.
Okay, cool. So in Lakey thing, which is our main lake, I've made a root file system, which is the container for an ADLS Gen 2 store. 3 root folders. So we've got our bronze, gold, silver. Love the order. And we can go in and we can secure that separately. And then in each of those, we can right-click, manage ACL, and then we can decide actually who gets access to these bits. So you've got read, write, and execute. Execute is essentially the ability to list the contents of that folder, which is just a really weirdly named thing, but parsing security controls, and then read access, write access. So you need access to that. And actually we want it to be set at this level so that as soon as we then tell Databricks and go, just start loading data into that folder, we've got these default permissions. And that means any child that gets created in these folders is going to inherit that permission. So if we're setting up any kind of security process, we need to have done that. And then we can hop over and go, let's start landing some data in it. Okay, right. So what we did, got our cloud file stuff. We've decided we're using rescue data. There we go. That was our schema location. So we got /mount. I put it under /lake. We're going into bronze. And then this is going to be ratings. And I think one of the things we can do as a future one is if you want to take this notebook and turn it into a fully parameterized, fully dynamic thing. I guess for now, we'll just stick with ratings and we'll land it as is and we'll see what it looks like, right?
Yeah, absolutely.
So we're going to have this bronze ratings folder. We might have more subfolders in there if we're doing a big organizational thing. We could have marketing as a folder that then contains all the different entities in there. We might even have classifications inside there. That might be, kind of highly confidential. And then we have a security setting on there. Whatever folder structure you want for your lake is kind of like where you pin your ACLs. So that's how you manage everything, right? So people say, what folders should I have in my lake? And it's like, what security contexts do you have? Because they're the things that you use to govern how your security works. So for now, we're easy. I assume we'll just land some entities inside bronze and we'll keep it simple.
Rock on, let's do it, man.
Okay, so we'll stick with that. And then that'll be the same place where we're going to go and put that. So that's just going to be ratings because we were just taking just Game of Thrones. We're going to just smash this all into one big thing. So that should be everything we need to actually get our data frame working. So let's just run everything. There is another option we could add called validate options. Oh, we don't have a schema anymore, but that's good because we do not have a schema anymore because we've decided to use schema inference. So actually, when we run this, it's going to go, using schema inference. It's going to go and look at the data. It's going to go and figure out what the data looks like and run a little bit of inference. And then it should, it's choosing a sample of files for schema inference. Oh, look at that, telling us what it's doing. And then we can go and have a look at the metadata and actually see this is what it found, and that should match up the data frame that gets created. I did a sample of 1,000 files. Well, we could have tweaked that and made it slightly more efficient, but it's fine. It'll be all right.
It's fine. It's fine.
Okay, so you can see this is the structure I found. It's got some nested structs. It's got some interesting stuff in there, and we've got rescued data. So it's gone off. It's done its inference. We can then dive over here back into Lakey thing. Inside bronze, we've got ratings, and we've now got underscore schemas, which has got a schema file called 0, because, and that is a little bit of metadata that basically just has that same struct in. That's according to autoloader, this is what the data looked like when we first turned it on. Now, because we're using rescue, that's not going to change. That's just set in stone. That is our thing. Anything else, if we got in another attribute called
You literally want to call it
well, yeah, we could have another attribute called
Yeah, I'm just saying, if you want to do that, you're fine.
Well, yeah, we could try it in a second, just see what it comes through.
Sure. Exactly.
Denny's rating system, if we started tagging that against things, would just get dumped into that rescue data, so the struct wouldn't change. So that thing would stick as 0.
So you're trying to imply whatever I do needs to be rescued. Got it. Thank you.
Yeah.
Thank you very much. I appreciate that. That's really nice of you, man.
Well, I'm assuming your ratings they're a cry for help.
Oh man.
And then, so if we're doing rescue, that's not going to change. If we said instead of rescue, we want it to be add new columns, then at that point, this is going to break. But if we went in here, we'd see number 1, and we'd see that schema evolving as it goes and correcting it. Oh no, we've got new things. I'm going to update the schema, and then you restart it, and then it works because that schema file's updating. As you can tell, I've recently been writing a talk on this thing.
Really? No, I'm not aware of that fact. Why don't you tell the audience a little bit about that talk that you're referring to?
Well, there's some conference thing coming up that I had to do it for. I don't think.
There is a conference. What conference is that? Oh, Karen, do you want to remind us what that conference was? I forgot.
It's the Data and AI Summit.
Oh yeah,
With the background, just to frame it
with the background.
Oh,
so are you trying to say that you're actually presenting at a Simon? Is that what you're saying?
I am. If you want a full hour of me wittering about autoloader, then you can come along and listen up. And yeah, which is why I have so many demos right now.
Exactly. So now you know the secret of how I do most of my sessions. I just make Simon do most of the work.
Which is why it then goes horribly wrong, and I've just missed parts.
Technicality. Cool. But so now what's great here is basically Simon's really eloquently shown the fact that basically you have your options for how to handle your schema drift, and there are actually valid reasons to even allow systems to break, right? Like, I mean, I freely admit the fact that that's not my favorite option. I'll freely admit, but there are in fact some customer environments that I've worked in where that's exactly what they want, right? Because what they're worried is that the entire downstream system actually is going to break based on the fact that there's a different column. It could be something as simple as my machine learning algorithm is not going to work because it's seeing another feature it doesn't recognize, to something as complicated as, like, from a security perspective, we're not actually supposed to receive additional data. So when we do, we actually are concerned about PII, right? So it can go all of the above, right? So there are actually valid reasons to do it. It's, again, not my favorite option, but completely valid. So again, autoloader allows you to do that, which basically break the system. It will stop, it won't process because of that. For the other two options, which are, admittedly enough, the more common options, right? The one that in which you're saying, let me go ahead and just keep on running. I don't even want to look at the extra column. Some folks do that. I honestly wouldn't suggest that, at least from my perspective. But again, I have seen specific customer scenarios where they're like, yeah, we know that this is all we want and we're done. The only reason I'm not inclined to say that is because in any aggregate or machine learning server, where you're putting the data ultimately into the gold layer of your lakehouse, the reality is, you know what data you need now. It doesn't mean you know what data you need a month from now, 3 months from now. And so because you don't know these things, it actually makes a ton of sense. And it's an additional column that has that information. It'll prevent your system from breaking as you're processing all that data. Yet at the same time, later on, we realize, oh crap, I do need to know what these additional columns are. Exactly how Simon's called out, all that information is there. Like, you don't even have to infer it. The literally autoloaders propped the schema in there for you, just as long as you specify, go save it. It actually specifies there so you can go know exactly what to get. So you don't technically need to even infer, because we can just grab the schema directly off that #1 file and grab it from there. Anything else that I missed that I probably should have added?
So the only one reason why we've used the fail and carry on kind of thing is delta performance. So if you've got like a whole load of attributes just piled into a string column, that's just a string. There's nothing on it. Whereas if you want to, you go, actually, we've added a new thing and we want it to do file skipping based on people querying on that thing from now on, then Delta's not going to capture stats on the individual attributes that go into that rescue data column. So if you need to actually go, oh no, that's going to be really important from now on, if you wanted to treat it like a first-class citizen of the thing and actually have stats captured in min-max and all that kind of thing, you want to ever be able to Z-optimize on it, all of that good stuff, you'd kind of want to make sure it's included. It's really rare we'd do that going into the raw bronze area, because you don't tend to have real performance-heavy tuning on it. But that's the one reason that we've kind of come across that you might want to do that.
No, that's actually a really good call out, actually. Yeah, I completely forgot about that. So it's a good call out. So again, I'm with Simon fully on this one, which is basically, I rarely see it applied at the bronze level, but definitely from silver on, you're going like, if you do need that, ever need to read it, yeah, you might want to convert it.
Yeah. Cool. Right. So we need to do, how long we got? Okay, we got 9 minutes. We're fine.
We got 9 minutes. We're fine.
We need to
right. We have to land. We actually haven't even landed, have we? Okay, my bad. No. Actually, let's see if we can do it in 5 or 6, because we do want Karen to actually end the show, so that way people can stop crying. Right.
Okay. Right. Yeah. So 2 things. One, in terms of getting data into the raw layer, I'd always add some kind of lineage, right? So, you know, quick. So we got basic, I want to be a data frame. I don't know. I know calling it DF is bad practice and people are going to be saying, you know, what is this joker doing? But, you know, it's fine. So just input file name. So that's, I just want to slap onto the data frame the name of the file it came from. When you're using things like autoloader, super important. So you can check which file did this come from? Is that a duplicate? Is that from the same file? Which one did it come out? All that kind of stuff. It was input file name. Yeah, there we go. So it's just going to update our data frame. So we've got that kind of bit of lineage just at the end. We might do load date. We might do load process, like cluster ID on it. All sorts of lineage. You might want to tag your file name, but at least we've got some kind of lineage on there. And then we want to write it out. I assume we're writing it out to a Delta table.
My goodness, yes. I think that would make a ton of sense. And don't forget, by the way, for you folks, if you're wondering, you actually can go ahead and get some of that lineage information, not the file name, mind you. Well, actually, technically you can, but it's a little bit more complicated if you actually just read the transaction log directly. But admittedly enough, I completely agree with Simon. Like, this is using source file input file name is such a handy little thing to be adding always. So absolutely, definitely do it. Yeah.
So something on these lines, we don't talk to, do we need partitioning in a raw table, or we'd only do that once we've actually figured out how we want to partition it? We've figured out, do we need to, depends how we're going to read from this table. And what we're probably
it depends on what we read.
And we can tinker it. We can refactor this code. It's fine.
Yeah. And not to mention, you know, this is relatively small, so we don't have to worry too much about it. But I can see, like, actually, if you're in a production environment where you would maybe partition by date or something like that, just to help things out. But for this purpose, it's probably okay.
So in this case, so I've assumed we're append only, right? So if the record already exists and we get an update from it, we don't care. That's just going to be another record in our raw table. Bronze table.
Well, then that seems to imply that later on we're going to have to figure out how to deduplicate or how to handle the updates or something like a CDC or something like that. Is that what you're trying to say?
Yep. So
perfect.
One of the next sessions will be, how do we go from bronze? How do we figure out, do we just take the new records? Do we merge it into silver and then we do CDC from silver? So we've got a bit of like figuring out that data flow to do to figure out what that looks like. But yeah, straightforward. Right, let's just run this.
So coming soon. Sorry, I was trying to do the coming soon. You're going to be able to do it.
Oh yes, sorry. I know Spark. What? It's not mode. It's the other word.
Option. Is it the option? Right. Or oh no, wait. Oh no. We should know this, shouldn't we?
Let me grab that from my other slide.
Oh man. We really should know this. Oh, that's horrible.
Oh, why are we doing this live?
Output mode. Oh my goodness.
Is it an option or is it output mode?
No, it's output mode. Yeah. At least I think it is, right? Crap. Or is it option?
It's not save, it's run stream. Why am I writing it in batch mode? Let me just double check this. Get the syntax right.
Okay. Oh, start.
Dreaming. All right.
Thank you, Rohit. Actually, Rohit just replaced. Rohit actually chimed in from within the chat. I'm wondering, should he just replace us, or at least replace me? So.
We need someone who knows what they're doing. Okay.
Yeah.
So I need to, of course we need to
check.
Oh
no, we forgot to specify the checkpoint location again.
Right, okay.
Yeah, I think we can do that.
So checkpoint location, I'm just going to put it into the same place. I'm going to put that as checkpoint.
Yeah, please. Don't literally put in the same place. That would suck, actually.
Okay, right. Format Delta. So the only other thing that we've got is if we want to have a trigger. So a lot of the time, if I'm trying to be slightly naughty and use autoloader as a batch process, which is why I'm very confused by lots of things, I do that, which is I just want to run it once. I don't want to leave this constantly streaming. I just want to, whenever I hit run on this, it'll go to the notification queue, figure out any files there, process everything it's missed, and then turn off, so I don't need to leave my cluster turned on. But I'm not paying for this cluster, so it's up to you, Denny. Should we leave it streaming until the next time we go, or should we leave it in trigger once mode?
Could you do it trigger once? I don't want to pay that much. Thank you.
Okay. So actually, we could have done even more. So what we'd normally do, if I'm doing a streaming query, I normally kind of try and capture the streaming object as well. So, I want my streaming query to be, and then that gives us an object strand query. It gives us an object we can actually then pull out attributes of to say what happened in that trigger one stream, what happened.
Oh,
yeah.
Right.
Okay, so that is running. Okay, we made it.
We made it. Woo! Or so. Okay. So we're actually almost done for today's session, but the context basically is by doing it this way, now as the data is coming in, as we're acquiring it from the lake or acquiring from the source, basically this data is now being dumped directly into our bronze section of our lakey thing. Wait, is our lakey thing our source or lakey things our lake?
Lakey things are lake, obviously.
Okay, sorry. Okay. Just realized, I'm like, I forget. So anyways, into our lakey thing, i.e. the lake. And so the context is now all the data sitting there. And just like Simon so graciously called out, yes, we're going to do trigger once. So that way, as new files come in, we definitely write there, but we don't actually need to go ahead and worry about keeping the cluster running. The cluster will in fact shut off when there are no new files. And then it'll be triggered once new files go in. All right. So now, actually, there's a great question for the final 2 minutes. Is autoloader overkill for daily files? Now, actually, I will put it this way. If you're talking about a single set of files once a day, it may be overkill. But even then, I'm actually going to tell you most likely you're going to go do it. And here's the reason why. Because to change from batch processing to streaming processing means all you can do is flip the API that you're reading here from write stream to write. Okay, so it's pretty straightforward. So especially when it comes to production environments, as you get more data, well, what's the difference then? Because after all, the cluster is going to shut down for you anyways when you're using trigger once. So let it run up. And then the idea is that you don't actually have to maintain it. New file pops in, cluster kicks back in, you get to see the data. So there really is this the simplicity of how you do job management when you're using write stream, okay, when you're doing streaming. Now, admittedly enough, it is a change of the way you're going to think about a particular problem. And even I'm, guilty of thinking in batch first. So it's not like it's a bad thing to do batch, okay? This is not an attempt to say that. It's just that there's a different context or different way of thinking when you do things in stream, when you're doing things in stream that provide a whole new set of advantages. And so I would not be, I would say that while your instincts are completely correct in saying that maybe it is an overkill, but I will tell you, as you do more and more production processing of data, you'll find that it's not only not overkill, but it actually simplifies things massively.
Yeah, I mean, so we found the same. So there are complexities that you add by switching to streaming. If you're trying to do anything that requires stateful streaming and deduping and doing anything like that, it's harder to do as a stream because it needs to be aware of previous context and manage state and use memory and all that kind of stuff. If you are using it fairly bluntly as a batch process to go, just take the data and append it in, the extra benefit you get of all that streaming, the schema drift stuff, super crazy useful. So yeah, it's the shift and balance of it saves you some complexity about working out which files you've read, but it costs you some complexity because it's streaming. And then suddenly, as we get more and more features like schema drift and things added into it, that just outweighs that balance even more to make it, yeah, it's really easy. And you can see we have data in our Delta table. That is, we have loaded raw or bronze with some data.
So we didn't completely screw it up. Awesome. Okay, it's 1 minute past the hour. I think we probably need to shift. So thank you very much for all of you who have decided to still continue watching us. We appreciate your time. Karen, we're going to switch back to Karen so she can close up shop. We will send out, the recording is already in YouTube, by the way. But in addition to that, we're going to chime in and ask you guys to vote later on what we should do next. We've obviously implied what we're going to do, but still, nevertheless, we'd love your feedback. Karen, please take it away.
Thanks, Denny. Thanks, Simon and Denny, for the session. I just launched the poll in the Zoom. So if you're joining us on Zoom, please vote there. And then I will, I'd love for everyone that's joining us on LinkedIn or YouTube, if you can join in the comments on the YouTube recording of what you would like to hear next, that would be great. So we can capture what you'd like to hear from us. Cool. So with that, I will say, I hope everyone has a great rest of your day and hope you join us for part 3 and for Summit coming up in a few weeks. All right. Thanks, everyone. Take care.
Awesome.
Take care, everybody.